Okay, hi everyone. Welcome to today's live coding session. It's nice to have you all here. I hope you guys can hear me. I can see Excel. I can see Towercult. Hope you guys can hear me clearly. Yeah, they say hello.
Yes, can. Hello.
Hello,
Hello.
we can hear you.
All right, cool. Welcome, Brother Silas, Andrew, Ade, Chijoke, Captain Michael, Duncan, Kelechi Okoro. Wow, that's my namesake. In terms of surname, we have Solomon. I can see. Okay, I think the right person just stepped out. All right, welcome everyone. It's nice to have you all here. This is day one for the live coding session. It's in the stage D phase of your Harmony training. So yeah, this I think the stage is actually more of a neural network and let's say more advanced modules. Right? So you just try to, comprehend all what I'll probably be saying, but I would strongly advise you also do more research outside what you learn here today, because obviously we can't finish everything in an hour. All right, so I'm just going to go ahead to share my screen so that we just get into it. Give me a sec. Okay. Let me know when you can see my screen. Is it visible now?
We can see it.
Yes.
All right, so yeah, once again, welcome. So we're looking at today we're just going to do an intro to neural network and Keras framework. Okay, we'll go on to the next slide. Okay, so we're going to start our journey into the world of neural network and deep learning. So over the next 4 days, we'll explore how to build, train, and deploy neural network using Keras framework. Okay, so we'll start with what is or what are NN. N stands for Traditional Neural Networks, and they are actually computational models inspired by the human brain. So they consist of layers that interconnect nodes or neurons, which process input data to recognize patterns and make decisions. So you can think of them as a simplified version of how our brain works. Okay, so we have some components of the artificial neural network. It has three main components: the neurons, the layers, and the activation functions. So neurons are basically it's the basic unit that processes the data, right? So just like the neurons in our brain, so it processes maybe the information we are getting through our sight, hearing, our sense of smell, right? So the neurons processes that data. Then we have layers. Layers are groups of neurons working together. Then activation functions decide whether a neuron should be activated. So this structure helps the network learn complex patterns, right? So the three main components are neuron, the layers, and activation function. So while neurons are the basic units that processes the data, layers are groups of neurons working together. Then activation function decides whether a neuron should forward and back propagation. The forward propagation is when the data moves through the network from input to output, generating a prediction. So Forward propagation is when the data moves from the network, moves through the, while back propagation adjusts the weights of the neurons based on the error of the prediction, helping the network learn. That again, it adjusts the weights of the neuron based on the error of the prediction, helping the network to learn. So it's like improving on it over time. I'm going to see how it works soon. Then this is soon jump to a notebook. So deep learning is a subset of machine learning that uses neural network with many layers. This deep network can learn powerful for tasks like image recognition, natural language processing, and more. So yeah, we're going to be making use of the Keras network. So Keras is a high-level neural network API written in Python. It's designed for fast experiment on top of back-end engines like TensorFlow, making it both powerful and user-friendly neural network. All right, have any question for me so far? Any question? Okay. But can you guys still hear me? Can anyone still hear me?
Yes, we can hear you, though.
Hello?
We all,
Am I still?
yeah, we can hear you.
I'm good, Rich. You need me for something.
I
Hi,
think
good
he has,
Rich. No, he's
he has
still
left.
here.
Wow. Hello,
Good
can
Rich,
you guys hear me now?
we can hear you. We could hear you. We could always hear you.
Please, please, where did you stop hearing me? Because I knew that the network kicked me out.
We were hearing you all along. Maybe you thought we weren't hearing you.
Oh, I just
Yeah.
recognize next. Okay. I was asking if anyone has any question. Okay. I think I'll just have to jump into the notebook. Right. Can you guys see my digital notebook?
Yes, we can.
All right. So it's what we have here is just it's something basic, right? So let's just try and follow so that you'll not get lost. So we're working with Keras, and this is how you install it if you're using I mean this is obviously how you install with Python. So let me just connect to my runtime. So it's already installed, like I mean Google Colab has it already installed. But yeah, that's just how you set it up, just in case you don't have it on your device. All right. So actually the slide continues from here. So yeah, I'll just continue from where we stopped on the slides. So we have basic Keras model, the sequential and the functional APIs. So these are the two main types of models. The sequential API is a simple stack of layers connected sequentially. Then you have the functional API, a more flexible way to define models, allowing for multi-input, multi-trade layers. Okay, so those are like the two main types of models you have under KRS. So here is us looking at our first artificial neural network with KRS. We are going to be working with the MNIST set. So MNIST is 1,000 images of handwritten digits, split into 60,000 training images and 10,000 test images. Each image is 28 times 28 pixels. That's the length and width. So we'll start by importing the necessary libraries we need. So the dataset is going to come from the dataset module in the Keras library. Then we are going to be working with the sequential module, which is just a simple stack of layers connected sequentially. Then we have two layers, the dense and flattened layers. Then, okay, for categorical conversion, NumPy, and then matplotlib. So let's take a look at the data first before I mean, this is where we split it, but let me run this. No, no, no. Okay. So this is actually where we split it into training and testing, but we are going to take a look at the data so we see how it looks like. So I'll do something like mnist dot load data. Though we say it's an image, but obviously we're not going to be seeing image, we're going to be seeing arrays of numbers. So each of these, first of all, hold on, because the way it's arranged in the training and testing. So if we subset the first one, we're going to get our training data. We're trying to break it down in as much as it's just number. At least you should know which one belongs to which one. So this first one now belongs to the training data set. Okay. And while the second one belongs to test data set. So inside it are like arrays of let's say arrays are like a series of different images. It says 60,000. Okay. So this is the first one. I think Google Colab is actually smart enough to know that that is an image. So this is actually the raw data. This is actually the raw data. But yeah, Google Colab was actually smart enough to, show us the image. Now I think I created please hold on. I created a function to plot an image. So let me see how I made it. Of it. So let me take this up. I'll copy this too. Just give me a sec. And this, let's just visualize it. Okay, here we are. So press the first one. Um, this is the first one, the function. The second one is where we reshape the data, but we don't need this because this was after prediction. So I'll comment that out. Then the last one. Okay. All right. Let me see. So, a second. Okay. Not too much time sometimes. Please just give me a second. If it doesn't work, we'll just have to flip it. All right. Coming this okay. I don't want to spend much time on that, but uh, let's say now it will take time. Let me just continue. When we get to that last part, we'll make use of the function. All right. Okay. So this is actually what. Hello, can you guys still hear me?
Yes, I can
Yes,
hear
we
you.
can.
Yeah. Well, let
Yes,
me
we can
just
hear you.
for now. All right. So we've split it. This is actually one of the data sets. You can take a look at another one just by indexing it. So this one is 0, right? Okay. So here is where we split it. We just unpack it to the training and the test. Okay. Then here is pre-processing. So before feeding the data into our model, we need to pre-process it, retrieve the data, convert the 28 by 28 images into a flat array of 754 pixels. Okay. Then normalize the data, scale it pixel values to like scale the value to 0 and 1, between 0 to 1, sorry. Then convert the labels to categorical. Let's see, they're converting actually the Y train. So let's see the content of our Y train model. Um, Interesting. Okay, let me see the difference now. Let's see the difference. Okay, so there's actually two difference. Before it was pre-processed, this was how the values looks like. You can see that the values were actually ranging, 5, 4, 8, and the rest of them. So what happened was we scale it down to 0, like the range should be 0 to 1. And that's what is happening. This one is where we shape it into categorical and normalize it. Inside category to just normalize the whole stuff from 0 to 1. And this is what the results look like. This is actually we're also reshaping it so that it also fits into the network we are trying to work with. So that's why I also reshaping it. Then we define the model we want to work with. It will have an input layer of 784 neuron, one hidden layer with one activation function. We say activation function is the one that decides if a neuron should be active or not. Then the output layer with 10 neurons. Okay, so this is where we're adding those layers we talked about. Then compiling the model. So this step configures the learning process. We specify the loss function as categorical cross entropy for multi-class classification. Then optimizer set it to Ada, which is an efficient gradient descent algorithm. Then the metrics we want to track to know if our model is doing better is the accuracy. So this is where we compile the model. Then we run it again. Okay, then we now then train the model using the data after we must have split it. You split, you do some configurations, which is just compiling, setting the layers. We're using a dense layer. Actually, we saw two different layers. We saw the dense and the flattened layers. So the dense layers, think of a dense layer as a densely connected network of neurons, right? Every neuron in a dense layer is connected to every neuron in the previous layer. So it's like a room where every person can talk to every other person's directly. Then flattened layer simply reshapes or flattens the data. So you can imagine it like you have a stack of papers with writings on both sides. Flattening them means spreading them out into a single layer so that you can read them one after another. So it's like taking a stack of books and laying them out flat on the table so that you can see all the pages. So that's like what the two mean. So we train the model using data we split. Then the number of time we want to maybe look through it, that's the number of epochs, we set it to 10. Then the batch size, 128. Then the validation split fraction of between data to use and validation data with 20%. So this is where we did that. And let me run it. So hold on. So it's actually going to be training it for 10 consecutive times. So it's like we said the number of epochs is how many times the model will see the entire data set. Right. So at the first time it saw the data set, this is the result it's producing. So it's seeing a loss of this, an accuracy of 0.91. So it's until 10. So if you also notice at every interval it's executing, the accuracy is actually improving. The accuracy keeps increasing till it's done. So this is just how it works, right? So you should probably reduce that number of epoch. It's also going to reduce the number of times it goes through the data to train on it. So let's break down all these results you're seeing, what they literally mean. So it's still running. It's done. All right, so I broke like I this result we're having here, right? I just broke down and explained it down here. So the line you're saying it's obvious what it means. It's just how many times sorry, the count of probably the rows of data it has, right, to the end. So it shows the number of batches processed out of the total batches. So it's fine in this case. Then we have the training metrics, which is the loss and accuracy, one, right? So the training loss for the first epoch, lower values indicate a better fit to the training data. So it means it's fitting well. Then this accuracy we have for the first one is the percentage of correctly classified samples in the training data set. So these ones are the training metrics, the loss rate, that is the value and the val accuracy. So with this value for the first epoch, this measures the model performance on the validation set. Lower values indicate a better fit. So yeah, this value is actually low. So it indicates a better fit. Then we have the validation accuracy. So this percentage This is the percentage of correctly classified samples in the validation set. So yeah, that is how you can actually interpret the results you have here to know if maybe you're overfitting or you're not overfitting. Then, like I explained, you are seeing the progress of the hip hop. So as it goes from 1 to 0, the training loss increase from 0.2986 to 0.09. Okay, so it's because I ran it again, that's why it's not matching, but it reduced from this value here to this value. Okay. Then the training accuracy increases from 91.5. So let's look at the one we have currently. It increased from 91.67 to 99.84. Oh, sorry, 0.9984. From 0.9167 to 0.9984. So that's the range it has increased to. Then we have the other one. So the loss fluctuates but generally decrease while the validation accuracy increases, indicating that the model is generalizing well to unseen data. The conclusion, just what I've explained. Now, obviously, for every model you are making use of, you need to evaluate to, know if it's already we've seen the evaluation, right? But yeah, this is also how you can print out the test loss and the test accuracy. And this is us evaluating the test data sets, right? How well it's going to perform. And this is the accuracy. Though we've not done prediction yet, but they are just testing it. We can see that it's performing very well. The loss is actually low. So this is where we make the prediction. We use the trained model after training it. Let me run this because we actually trained it again. Okay, the accuracy is now 0.97. All right, so we would pass in the test data set to predict. So after predicting it, we can then visualize. So you should know that before you trained the data, it was actually converted, right? It was converted, you resize it, right? So for you to also maybe see the output, you need to take it back to its previous shape. So that's what is happening here. We reshape it using the reshape method to reshape the data back to its normal shape. Then we just plot the first 10 rows of information. We can actually increase it to 20. What is that? Prediction is not defined. I may have mistakenly used euro or alternate spelling. Yes. Oh, okay. Don't think I did not run this, so sorry. So this is where the predictions is coming from. Okay. All right. So this is what I know. This is still clustered. Hold on. Let me see if I can size this right now. Not to work. Well, number of integer with num less than 12 is not 13. Okay, I think I'll just make it 2. Okay. Right. So what we are seeing here is the test data and the predicted value. So right now everything is like perfect, right? So this is the true value, these are the predicted value, and just below it is or are the images respectively. Are the images respectively. All right. So yeah, this is just a how you can set up your Keras model to, you know, do some predictions or classification in this case, right? You bring in your data sets, split it, you create your model and, design some layers, after which you now then train the model, then you use it for prediction and then evaluate if your model is performing well or not. Does anyone have any question for me? Any question for me? Let me check the chat box. How do I handle the TensorFlow data sets only support Python to handle? The question is not that clear, but it sounds like you are trying to access TensorFlow data sets. What kind of error are you having? Maybe you should send the error message you're getting. Then another thing too I can tell us is I encountered it when I tried to run the codes from the lesson. Oh, okay. Let me see. Let me try importing it here. Okay, so while I'm trying to resolve that, does anyone have any other question for me? Um, okay, let me try it on my end and see. Okay. And interprets abstract class activity. Okay. You probably want to take we have to take this online and research to see what the issue is. If you can fit and validate at the same time, can you fit and validate at the same time? I'm not sure I understand. Is it like if you can write that in a single line of code, or you can quickly um maybe evaluate your model after fitting it in. Then for this error, please, if it has to do, okay. I'm not seeing anything helpful online. So I'll just advise you to maybe check online why it's not working. Oh, okay, 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 okay. Um, I'm not sure. Um, Keras has a way of taking in validation data sets, but I think it does that inside while it was actually training the data. Because if you notice from the output we got, we have a validation score and that's validation loss and validation accuracy. So I think while it's actually training, it's doing the validation. It's doing the validation inside. Where is it? Let me go back there. Yeah, yeah. So here is actually where we set it. You see this validation split. So in essence, what it's doing is while it is on this first line training it, it probably is going to take 80% of it, right? Inside it. I'll say it's going to split it. So 80% in that first batch will be used to train. Yeah, to use the other 20% as validation. So that's why this guys it's training and it's also validating. So it's okay. Let me see. There's a parameter for that. So if you want to pass in your validation data, let's say you have like a different probably a series with your validation data set. You can just use the parameter validation data and then assign it to the variable that is holding it. Okay, so either maybe like in this case, we don't have validation data, right? So that's why we're asking it to split it from the training data set. But if you do, yeah, just make use of the validation data parameter and then assign it to it. So in essence, what I'm trying to say is, let's say before you split it, give me a sec. Let's go back. So let's say after let me come in here. Let's say after you split it, for instance, and you want to maybe have validation data set, we can do something like let's say x val equals to x underscore train. Um, let me check. Hold on, let me check the length. It's 60,000. Okay. Let's take at least 10,000 samples from from the egg train. Then your while validation, you can do something like this too. Please hold on, let me validate this. See, this has a real, okay. So you can actually subset. My point is, if you want to work with validation data, you can actually split it. Okay, you can actually split it. So that's what I'm trying to do. Okay, no. This is not the right way to do it. Come in. Okay. So from minus 3 is going to be from here to the end. Okay. Okay, so let's take the last 10,000 samples as our validation data set. So I'll do something like this, minus 10,000. So this will start from 10, like it's going to extract the last 10,000 rows as validation. Then we can do the same thing for our Y validation. Okay. Then the remaining ones now will now then be used for training. So we are going to subset down to the last value. That's where we started the other one. Sorry, why? Okay, so we have this. So if you want to fit this in now, you say model dot fit pass your X string, your Y string. The next thing should be your number of epochs, or yeah, it seems you are using what's it called? Keyword value. So you can just start with batch size. 128. Hold on. By number of epochs, you can still use. Okay. I think this was initialized before. Why is it model showing it here? Yeah, not as much. Let me just take that down. So after we brought in the model. Okay, so here it is. I'm just going to run this. So for the person that asks if how you pass in the validation data, that's how you can actually do it. Yeah, welcome. I'm waiting for it to run, taking time. So most of the data sets, especially like challenges on cargo, they usually give, yeah, not as much. They usually give validation data, right? So it's now left for you to make use of it. Give me a sec. Okay, 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 okay. I've seen what's the issue. Sorry. Sorry. Okay, does anyone have any other question for me? So this is just going to train the model, and we're going to have eight epochs with some results, accuracy, and the rest of them. Yeah, I'll show the notebook. What's going on? Validation data is not defined. My bad. Sorry. Sorry. Yeah, it will work fine. Okay. I think I'll just have to um I'll need to resize and preprocess it already. That is where I would have done that too. Well, yeah, you've seen where to pass it in. So why it's showing that error, you can see what is happening. It's talking about sequential incompatible with the layer. Expected this shape but found this. That's because I've not processed the data after converting it. Okay. But once you do that, it's going to work just fine. When reshaping the images, should it be applied to all the training validation and testing data sets or just a select split? Already you're seeing that it's throwing an error. So you can't maybe train it with a cat and you're trying to validate it on a dog. So they need to be on the same level. Already the sequential model we are using expects the shape to be in this format. So it means that everything, both the validation and testing, needs to be in this format so that it can easily compare and match if they actually perform what it needs to do on accuracy and the rest of them. For encoding level to categorical, do I apply to all the data set? If the data set has a categorical field, yes, you apply it. Here, we actually made use of it, but I think the way the function is, it also has a way of normalizing it because this was just reshaping it. So here it's just going to turn it categorical. And we had one result I printed out earlier. So yes, you apply it on the training and the testing data you're working with. Yeah, I'll send you my notes through. Okay, it's already time. Uh, just give me a sec. So I'll be dropping the notebook link. So you just pick it up and go from there. Okay. Let's check the same thing. Thanks. Oh, please, guys, I'm coming. Network is very terrible. Oh my God. Let me, let me, my network is hanging. Please give me a sec. Let me try it on another side.
Good Rich, your time is
I'm
up.
trying to get the link. It's not letting. Yeah, I know. I'm trying to share the link to the notebook. It's taking time. Okay.
Hello, hello.
Hello.
Yes, please.
Yeah, I can hear
I,
you.
I, yeah, okay. I made an observation when I tried opening the notebooks you gave during the last session. Two of them were not opening. I think I talked to one or two other people and they experienced the same thing. So I don't know if it was just us or it's a general thing. So if they could be dropped also,
Wasn't
I would
open.
appreciate it.
Because just what?
Yes, the one of the second session and the one
Sorry,
of the
when you go
last
click on the
session.
link, what happened?
It was just bringing out numbers. I think it came in
No,
raw
no, no, no.
format.
Download it. Download. Yes, that's because you need to download it to your device. Then you open it using the correct ID, either your VS Code or Jupyter Notebook. You understand?
Okay.
Okay, I've gotten the link. I'm going to paste it now. So yeah, what you saw is just how it's going to look like. The time is already up. So just download, click on the download it. So download as a Jupyter Notebook. Then you can now open it using a proper ID. Why it's showing like that is because obviously you can't view it from just normal text viewer. I've dropped I think the access was visible to everybody. So whenever I see that whole number, I've dropped the link. So my time is up. Uh, yeah, just pick up that link in the next few minutes. All right. Yeah. Let's see, maybe by 3:02 you can end it.
Good Rich, you have to be the one to send the notebooks because the only way I can send it to them is if I know the number of people that attended class today. And that will be quite difficult. It's best to send it to them right now.
I've sent the
All
link.
right, we are delaying the other
I've
class.
dropped
Is
the
there a way
link
we
to
can wrap
today's
this up?
notebook. No, no,
Okay.
I've sent the link to today's notebook. I was saying that we should just give them the next few minutes, then you can end the meeting. I'm done. I'm done. I'm done. I'm done.
Okay. It's all right. Then I believe they should have copied the notebooks by now, so they should have gotten the links rather. So I would end the meeting. Thank you, everybody.